July 19th, 2026, the day of the World Cup final. Spain against Argentina, MetLife Stadium. Hours after the final whistle, a mathematician named Levent Alpöge posts a tweet. Quote, "Hello there. The Jacobian conjecture is false, thanks to my close friend Arkil for asking about it, and my other close friend Fable for working during the World Cup final. Attached, 3 equations. And if those equations check out, a math problem that's been open since 1939 is dead." They did check out. Within hours, mathematicians are confirming it in public. Easily verifiable symbolically, one posts on Math Overflow. The top comment on the math subreddit, "Normally I would be extremely skeptical, but the result is checkable by simple computation. Remarkable." Wikipedia's editors, meanwhile, are fighting about whether a tweet is allowed to kill an 87-year-old conjecture. Math doesn't wait for sourcing policy. The tweet is 3 equations and a joke. Everything around it is the story. What the problem actually said, it's friendlier than the name. The mathematician who lost 7 years of his life to it. And what happened 2 days later when everyone with a subscription decided to try this at home, which is where this stops being a math story. First, the scene. Alpöge is not some random account. Harvard valedictorian, Morgan Prize winner, junior fellow at Harvard, works at Anthropic. His most recent paper settled a Hilbert problem from 1900. During the final, his friend Arkil asks him about the Jacobian conjecture, one of the central open problems in algebraic geometry. So, Alpöge puts it to Claude Fable 5, Anthropic's newest flagship model. And Fable comes back with a counterexample. 3 polynomials, posted at 10 that night. No paper, no announcement. So, what is the Jacobian conjecture? The name is scarier than the idea. Imagine a machine that eats 3 numbers and spits out 3 numbers. Each output is just a polynomial, powers and coefficients, school algebra. Now, this machine has a speedometer. That's the Jacobian. It measures how much the machine stretches space at whatever point you're standing on. If that speedometer never reads 0, anywhere, then up close, the machine is always reversible. Around every point, you can undo what it does. The conjecture says, then the whole machine must be reversible. Locally undoable everywhere means globally undoable, period. Sounds reasonable. Mathematicians thought so too, in 1939. Smale put it on his list of the great problems for the next century, and then it ate everyone who touched it. In 1985, a PhD student named Yitang Zhang arrives at Purdue and tells his advisor he wants to prove it. The advisor, T.T. Mo, thinks it's a strange choice, way too hard for a thesis. Zhang spends 7 years on it. Near the end, he believes he solved it, tells people he solved it. The proof has a hole. It collapses. He graduates with no publications in the field and no support from Mo, no academic job. A friend opens a Subway franchise, and Zhang, a man with a Purdue PhD, keeps the books. And Mo's own written account of those years is public. He says Zhang, quote, failed miserably. That Zhang, quote, wasted 7 years of his own life and my time. That's not how Zhang's story ends, though. He eventually gets a teaching job. Lecturer, University of New Hampshire, no tenure track. He switches fields entirely. And in 2013, at 58 years old, he cracks one of the biggest problems in number theory, bounded gaps between primes. MacArthur Fellowship the year after? One of the great comeback stories in mathematics. Mo, meanwhile, is proud of his own role. His own words, a gatekeeper of the palace of the Jacobian conjecture. He examined every claimed proof that reached him and turned them all away. And he once wrote to a young mathematician attempting it, quote, "Perhaps it will take human being another 100 years to solve it." Back to the tweet. Here's the counterexample. 3 polynomials, you're looking at them. This machine's speedometer reads -2. Everywhere, always, never 0. And yet, Alpöge lists 3 different input points, exact coordinates, that all come out at the exact same output. 3 points in, 1 point out. Run the machine backwards from that output. Which of the 3 do you return to? You can't decide. The reverse gear doesn't exist. The conjecture is false. And the thing was hiding in plain sight. Everyone hunting a counterexample assumed it would be a monster. This one fits in a tweet. And you can check every word of this. 2 computations. The speedometer, a 3x3 determinant of derivatives, first-year calculus, comes out to -2. Then plug in the 3 points. Same output every time. His thread links Wolfram Alpha doing both halves. You can verify the death of an 87-year-old conjecture on your phone in less time than half time. Which matters, because most AI output is debatable. Is the essay good? Is the image beautiful? Is the code right? You can fight about those forever. A counterexample is binary. Right or wrong. Checkable by anyone. No taste involved. You don't have to trust Anthropic. You don't have to trust Alpöge. The object verifies itself. Hold on to that. It becomes important. One honest caveat first. This wasn't AI alone. Alpöge knew what to ask, and he knew what he was looking at when the answer came back. He hasn't published the chat transcript, so we can't say how much was the model. The math checks out either way. But the question, how much does the expert matter, didn't stay open long. 48 hours later, a stranger answered it from the other direction. July 22nd. A guy named Dmitry Rybin posts the Dinit-Garg-Goens conjecture, a graph theory problem open about 30 years, is false. Counterexample from GPT-5.6 Pro, and he attaches the full chat. The whole thing is 4 prompts, 58 words. The prompts are like, quote, do a breakthrough and find a structured counterexample, and continue. At one point, he tells the model, quote, had enough of your failure. Please finish with complete unconditional counterexample. Within hours, someone else on X extends the counterexample into an infinite family. And the internet has a name for this now. Vibe math. Like vibe coding, but for conjectures. There's already a tracker site, Vibe Mathed, counting 69 problems resolved by AI. Someone built a tier list of 155 famous problems to point the models at. Millennium problems are S tier, obviously. People are joking, half joking, about proving the Riemann hypothesis by typing continue. And one Reddit comment under the Rybin thread captured the mood. Are any of you doing it right now? Because you can. And if this feels familiar, it should. We already watched this movie in software. Programming used to be gated by syntax, years of learning the notation before you could build anything. Then AI showed up, and suddenly anyone with an idea could ship an app. Vibe coding. Some of what shipped was great. A lot of it was broken in ways nobody checked. Math just got the same update. The notation, the machinery, the decade of training, that was the gate. The gate is now optional. And somewhere out there is a person who always bounced off math class symbols who's about to discover they actually like math. That's a real upside. But the second half of the movie applies too. Because here's the honest question. Do you need to be an Alpöge? The week's 2 results point opposite ways. Jacobian, elite mathematician, unpublished transcript. Did it's 58 words, and one onlooker summary was, quote, basically no thinking from the user involved. Meanwhile, Terence Tao, by most accounts the greatest living mathematician, posted his own ChatGPT session digesting the counterexample. And he prompts like what he is. Short questions, dense jargon, steering the model hard. His read on the wave, the long tail of obscure problems falls to anyone with a subscription. The famous ones still take someone who knows what they're looking at. Tao called this in 2023, by the way. He said 2026 level AI would be a trustworthy co-author. His verdict now? It's ready for prime time. Now, the catch, and it's the part that outlasts the meme. Counterexamples are easy to check. This whole video is proof of that. Proofs are not. The Erdos problem site, where a lot of these AI wins get logged, now has a disclaimers page. Some open problems were just obscure, and some AI solutions turned out to be rediscoveries of published results. Tao's warning is sharper. Models write arguments that look polished while hiding the weak step. So mathematicians' inboxes are about to fill with vibe math proofs, and every one of them costs an expert's time to check. Math does have its own version of unit tests, proof assistants like Lean, where checking a proof literally means running it as code. Expect a lot more of that, and expect the new etiquette to harden fast. Before you publish a conjecture, run the strongest model on it yourself first. And zoom all the way out, because this part is bigger than math. Generation just got cheap. Verification didn't. That's the whole story. In code, we learned it the hard way. The AI writes the function in seconds, then a human spends an hour figuring out if it's lying to them. Math is learning it now. Every field these models touch next will learn it too, in its own accent. The bottleneck of progress moved. It used to be intelligence. Now it's trust. And the tools we build to check things are about to matter as much as the tools we build to make things. So here's where this leaves you. The lists are public. 1,000 Erdos problems, a tracker with 69 down, a tier list telling you what to attack next. The models are a subscription away. Mo gave this problem 100 years. It took one football match. Someone watching this video will kill a conjecture this year. Maybe by typing "do a breakthrough." Maybe by just typing "continue." If that's you, amazing. Tweet it. But check your work twice first. The whole internet is about to.